being obsessive compulsive about things like that. Okay, so the rest of this session will be chaired by Mikhail Pakhaday, who is now back. And from what I heard, he successfully submitted the grant. So congratulations, Misha, fingers crossed.
Yeah, we finally got the grant in today, so hopefully it's
yeah.
The result's only going to be in a year, so too early to drink champagne, but maybe hopefully next year we will.
Yours, man.
Okay, so let me please introduce my wonderful colleague Anna Petrova. So Asya is interested in bilingualism and is leading together with Andrei Mechikov a research line focused on the neurophysiological and behavioral aspects of native language attrition. And so she will present us the talk Spatial Bias of Valency Words in Second Language. Asya, please, when you're ready, share your screen and we are ready to listen to you.
Thank you very much, Misha, for this introduction. Can you all see my screen?
Yeah.
So there, I changed the title of the talk a little bit, but the essence is the same. Basically, we're studying the embodied lexical access to emotionally balanced words in bilinguals. Basically, the theories of grounded or embodied cognition theorize that linguistic representations are connected to our sensory motor experience. That is, in simple words, the words, linguistic items, they elicit activation of the sensory motor associations of those words. For example, some words may have typical locations, like objects that occur in a particular area of the visual field, or action words, or direction words. Then we all know about the effects of mental number line when smaller numbers are to the left and larger numbers are to the right, and the snark effect and such. There's a lot of embodied effects where semantics influences our spatial behavior and attention. For example, we can talk about objects that typically occur in upward locations like birds or hats or airplanes. And vice versa, there are objects that typically occur downwards like snakes, floor, asphalt, whatever is associated with downward space. And in experimental paradigms, language embodiment is evidenced by the results that when a word is presented in a congruent location, that is, the word bird, for example, is presented in the upward portion of the display, the reaction is faster than when the word is presented in incongruent location. For example, the word bird is down, which is contrary to its typical location. So there's a lot of evidence of that. For example, in Jandomian's work, it's been demonstrated that words for flying animals are judged faster when they're presented in upper portion of the display. And Swan and Yaxley demonstrated that semantic relatedness of words is judged faster if they're presented in positions corresponding to their locations, like attic and basement in this example. And the typical experimental paradigm is that of spatial cueing, when the word itself is presented centrally, and then there is a spatially displaced probe, and the task is the probe detection or the probe identification. And the probe location is congruent or incongruent with the word. I'll just show an example. For example, we have the fixation cross, and then we have the word in the center. And then we have a blank screen, and then a probe, a target, a square, a circle, a letter, or something that is up or down, or for that matter, it could be left or right if we're studying horizontal embodiment. And yeah, and then the task is the probe identification, and usually the response time is faster when the probe location is congruent to the word location. But so far we've been talking about concrete words like concrete objects or verbs, birds, airplanes, hats, and such. But what about abstract concepts? Intuitively, we think that abstract concepts can also have spatial associations. For example, all things good and happy direct our attention upwards, while all the things bad and sad direct our attention downwards. And indeed, there is experimental evidence that positive concepts are associated with upward space and negative concepts are associated with downward space. And Verges and Duffy, for example, demonstrated that imageability, the concreteness of words, has no significant effect on the embodiment effects, that abstract words are embodied just at the same level as the concrete words. And Gottlieb, Chastain, and Pratt demonstrated that positive emotional valency is attributed to upper space and negative is attributed to lower space. And then the next step is, so far we've been talking about words of a native language, and we thought of a question: what happens to a second language? Can a non-native language be embodied at the same level or be embodied at all? Because when we acquire our first language, we acquire it together with the sensory motor experiences associated with the words, with the verbs, with the directions and everything. So the first language is learned by direct association of words with the objects, with the actions, with the physical world. And a late acquisition of a second language does not involve direct sensory motor experience. We learn it by association, we learn it through the context of the first language, but it has no immediate physical context itself. So we're wondering whether the access to the second language is mediated by the first language, or does it become direct at some point? And if the second language is embodied, how it is embodied, and what are the differences with the first language? And to study that, the previous evidence also shows the sensory motor biases with accompanying the access to L2 words. At the behavioral level, there's evidence of activation of sensory motor information in L2, but it's weaker than in L1. And also it's been shown on the neural level. For example, our colleagues Nikola Vukovic and Yuri Shterov showed that there is activation for both languages, but it is stronger for the first language. And then there is the famous foreign language effect that shows us that in affective processing of L2, there is less automaticity. The foreign language effect itself shows the more rational decision-making in a second language. And that means the emotional detachment from the words of the second language. And that, again, poses the question whether the second language is processed in a completely different way than the first language with regard to the emotional and affective side. And we're working with emotionally balanced words. In the foreign language effect, there is this task that the two options are really the same. But in the first language, the participants tend to choose the risk-averse frame to save more people. And in the second language, there is really no difference between the two versions of this task. So basically, people behave more rationally in the second language. And in the present study, we're testing whether the embodied effects work in the second language, and if they do, how they work. We work with emotionally balanced words. We use the localization of the database by Bradley and Lang, the validated and tested many times, and Olga Marchenko, a colleague from Moscow University of Psychology and Pedagogics, kindly shared her database of those stimuli translated into Russian and validated on a large sample of participants. So we have stimuli in Russian and in English, separated by their valency, arousal, and dominance. And we have the visual probe detection task, which is presenting a square or a circle in a congruent or incongruent position on the screen. And we also assess the participants' L2 proficiency with the short Cambridge English test that's usually used for defining the level in the framework of A1, A2, B1, B2, etc. So in our paradigm, it was just as I described in the beginning. We presented the words centrally, and then we just presented the probe that was displaced either upwards or downwards. This is an example of a congruent probe. So for the results, we found in general shorter reaction times in the first language than in the second language. And as expected, the congruent probes were detected faster. What's interesting is the proficiency effect. The reaction times in the second language reduced with the increase of second language proficiency, which basically leads us to think that the more the person is proficient in the second language, the more embodied the second language becomes. Basically, the more similar it is with the first language at the level of embodiment. So the general graph looked like this. For the first language and the second language, the directions are actually opposite. But with proficiency, this difference subsides. This is the results by congruency. We see that congruent probes are detected overall faster. And this is the result by proficiency. It seems to be all over the place, but the general trend is that from the higher the proficiency, the lower the RT. The trend is going down. So the possible conclusions is that L2, second language, emotionally balanced words do elicit sensory motor activations, and the activation still is faster for first language words because of possibly lesser degree of automaticity in second language processing. The difference is more marked for negative words, and that second language sensory motor activation grows faster with proficiency because possibly the automaticity is increasing. And next step, that is, the data's been collected and it's now in progress of analysis. We are doing the eye tracking study of the same paradigm, and we're really curious to see what comes out of actually an objective eye movement measure. It's going to be probably a more precise information to add to this, but so far I can tell you this, and thank you for your attention.
Thank you, Ася, for this wonderful talk. Okay, so we have some time for questions. Feel free to ask questions by raising your hand or by typing them into the chat.
I can probably stop sharing.
I have some applause from Zahar. Thank you.
Thank you.
While people are thinking about their questions, can I ask a quick question, Asa?
Sure.
Right. So would you predict, given the data pattern, especially that divergent data pattern in concurrency interaction, would you predict that there may be even a sort of a priming effect where you could prime across L1 and L2 between primes and targets that share spatial locations or spatial biases beyond their lexical, but while being lexically completely unrelated? So in other words, would you predict the word, I don't know, eagle to prime word happy?
That's an interesting question. I think it will be hard to distinguish whether, if we see the attention shift from the word happy, it's hard to distinguish whether it's primed by eagle or the word happy elicits it by itself. I don't know if we can see a difference between like happy preceded by eagle and happy preceded by snake. I don't know if there's a ceiling effect.
Yeah, that's what I meant.
Happy activation.
No, what I meant is that if you forget about the visual probe detection task, would you predict just a lexical type priming, a reaction time priming outside of locational processing between the words that share that component, but they are not lexically related? So you wouldn't predict lexical priming between these words, but you would predict something like embodiment-based priming.
There are actually conflicting thoughts in my mind, because now I also think of the inhibition of return, this effect when actually once you've detected something in the upward space, then you're like temporarily blocked from perceiving that space. And if we are thinking of a priming effect, maybe it can show up as a reverse effect. Like if we see a delay in interference, then it means that we have a priming effect. That could be a thing.
Thank you. There's more questions in the chat. I can see.
I will read starting from the first one. Okay, so the first question is from Natasha Luciana. Excuse me if I pronounce it wrong. How did you determine which emotions were up or down?
Well, it's a very well-tested and validated database by Bradley and Lang. So the emotional determinants were tested on large samples of participants that rated them and then re-rated them. It's gone through a series of tests, and it's a database that's used widely. So we were basing off of actual material that already exists. We didn't create it from scratch.
Okay, so the next question is from Calliope. How do you explain that differences were more marked for negative words?
That actually the measure, there are several measures in the database, and one is emotional valence, and the other is arousal, which is basically the strength of the emotion that this particular word produces. And generally, typically, negative words tend to have slightly stronger arousal. Basically, the negative is more negative than the positive is positive, if I may say in simple words. So probably it's an effect of those secondary factors like arousal.
Okay, so we have one more question. It's from Christina. What about cognates? Have you looked at those? They should elicit faster reaction times, shouldn't they? Since they would activate both L2 and L1.
Well, we did not look at cognates, but I think it's problematic to find cognates that have the same emotional valency in the two languages because probably, like, oh no, I'm thinking homographs, but no, we did not look at cognates. I'm thinking they would probably even elicit interference because of the simultaneous activation of the two languages. Usually there is the switching costs, and in bilingual studies, cognates are usually processed slower because of the simultaneous activation, I think. But it's an interesting thing to look into. Maybe we can try and plan another study at some point for that.
Okay, I think we should move on to our next speaker. Thank you very much for your talk, Asa. Thank you for your questions, dear colleagues. If you have any more questions, you can ask them. Oh, yes, so Andrei is suggesting that arousal is something we should look into, Anna.
We are looking, yeah, we're considering it in the analysis. Thank you very much. Thanks for your attention. Thanks for the questions.